We are going to continue where we left off on the last lesson. We're going to talk about the unusual kinds of graphs and how to find the area between those curves. So, next example is going to be y equals the square root of x and y equals x minus 2, and I'm telling you to look only in quadrant 1. Only in quadrant 1. So now, if you would take your calculator, and we're going to graph this. Now remember, what zoom did I tell you yesterday was the best one to do for these? Zoom 4. Boy, the lighting is horrible. Oh, just back up a little bit. There we go. So we're going to go y equals, clear out what's in here, the square root of x, and then the other line is x minus 2. Go ahead and do a zoom 4, even though it says quadrant 1. We'll take a look at that, and we'll just draw quadrant 1 if that's a good graph. Okay, that is a good graph. So I only want you to sketch quadrant 1. So you're going to draw your x and y axis and draw that unusual shape in there. Kind of looks like a bird's wing to me. So it goes like this, and then it goes like this. Just only draw quadrant 1. Do not go down to quadrant 4. Okay. I will tell you in a minute why, but you are going to need to know where this point is. Can you tell by looking at the calculator where this line hits the x-axis? It's at 2. So put a 2 on your graph, please. Okay, I'm going to put the calculator aside for a minute, and I'm going to start drawing my vertical lines, and I want to show you what happens when you do. When you start at the left and start drawing vertical lines, are you hitting both graphs? No. You're only hitting the square root graph and the x-axis. So in this case, the top curve is the square root. The bottom curve is the x-axis. So, and that's going to happen until when? 2. Until I get to 2. And once I get to 2, I'm going to switch colors here, and I'm going to show you that now we actually are hitting both graphs. Do you see that? Mm-hmm. Because the top and the bottom curve change at a specific point, we have to set up 2 separate integrals. So I'm going to set up an integral for what's in red, and then I'm going to set up an integral for what's in blue. Okay, for the red area, well, first of all, I need to denote which one is y1 and which one is y2. So what did I put in the calculator as y1? Square root of x. Okay, so I'm just going to put a 1 right there and a 2 right there. And on the homework page, you can do that. You don't have to recopy the equations. Okay. So, in that first red area, what is the top curve? Y1 or Y2?
Y1.
Y1. And the bottom curve is y equals 0. So you could put minus 0, or you could just leave it off. I'm going to go ahead and put it, just for emphasis point, dx. What are my limits of integration? Where do my x's go from? 0 to 2. Does that make sense to everybody? Okay. Then to that, I'm going to add the integral from 2 to, I'm not sure where yet. I'm going to need to find that point in a second, but let's go ahead and write the rest of the integral down. What is the top curve in the blue area? Y, which one? 1 minus y2 dx. So now I need to go back and find that top limit. So I need my calculator again. So let's go back to the graph. I need to do an intersect. Second trace, intersect, enter, enter. We'll go to, I'm guessing it's around 4. And I am right, it is 4. So this one goes from 2 to 4. Now, I am going to go ahead and write down the coordinates right here because I'm going to need them later for something else I want to show you. It is 4, 2. Okay? You can type this entire thing into your calculator on one line, and that's what I want you to do. So go ahead and take your calculator, go to the home screen, and type this in like we did yesterday. So it will be Math 9 from 0 to 2. of just y1. You can put the minus 0 if you want to. Dx. Oh, that's really dark. Let's back off. Plus alpha trace and enter. Then math 9, 2 to 4. This one is y1, alpha trace and enter, minus alpha trace 2 and enter, dx. Push enter. It's got a lot of work to do, so it takes a little bit. And our answer is 3.333. It would look like 3 1/3, except for that 544 on the end. And sometimes you do get margins of error when you do the math. Okay? So, that is the area of that thing right there, completely. Approximately 3 1/3 square units. Okay. Do you have any questions on what I did? Okay. Now, I am going to show you how you can take this exact graph and do it with one integral instead of two. Okay? And it's a little bit of a change, and sometimes this method is better to do a problem. So I would like to keep this on the screen because I'm going to need the information. I need you to redraw that graph. Empty. Do not put lines in it. Just redraw the graph for me. This is an alternate method. Should have written this down first, but that's okay. And go ahead and label the points that I mentioned earlier. Everybody got it drawn? Okay. Don't need the picture anymore, so I'm going to scoot it up just a little bit. What we're going to do is we are actually going to draw horizontal rectangles. We're going to draw horizontal rectangles. Now, if you draw horizontal lines instead of vertical lines, are you going to hit on one end one graph and on the other end the other graph every time? Yes. Whether you start down here or whether you start up here, you're always going to hit the line on one side and the square root on the other. Do you agree with me? Mm-hmm. So they're all going to be the same. So that means I can do it all in one integral. But it's a little bit tricky on how we do it. And that's what I want to show you. Okay. For this problem, the width of your rectangles, is it a change in x or a change in y for the width? It's a y value because it's vertical. The width is vertical, so it's a change in y. The length, however, I want to talk about that. How do I find out how long that is? McKenna, you're actually right. Let me show you. You are actually right. No. I'm very impressed because I haven't had anybody get it right before. That's what I'm saying. Okay, if this, let's say that is at 3 and this is at 1. How do you calculate how long that is? That one minus this one. Do you agree with me? So we're going to write this as f of y minus g of y, or we can call it x2 minus x1. Now, when we did it vertical, we said top minus bottom. How would we say it in terms of direction for this one? Right minus left. Right minus left. Right minus left. So the integral area is going to be the integral from C to D. Now, why did I not put A and B? Because these are y values, not x values. C and D are y values, okay, of f of y minus g of y dy. Now, for these problems, and you'll see in a minute when we do one, you can't type in a y1 and a y2 because you can only type functions in the calculator. It doesn't work that way. We have to type in the equations to do these problems. So let's go ahead and finish this problem out. Let me recopy the equations. Y equals the square root of x, and y equals x minus 2. Those were the two equations we were dealing with. The first thing you must do is solve them both for x. They have to be in terms of x. So, what is the first equation in terms of x? What does x equal? Y squared. And the other equation, x equals what? Y plus 2. Okay? Now, because these are not in the calculator, I don't care what you call them. I'm going to call the first one 1 and the second one 2. It doesn't matter. It's just for helping you set up the problem. Okay? Now, based on my picture, which of the two graphs is on the right? The second one. So I'm going to write the word right here and left right here. Just like yesterday, I wrote top and bottom. So that when I set it up, I remember what I'm doing. So this is going to be the integral of x2 minus x1 dy. And that may bother a few of you, but yesterday we were saying y2 minus y1 dx. They're always different. But I can't type this in the calculator. The calculator doesn't understand an x2 and an x1, so I have to write the equations themselves down. So here's what you're going to do. Well, before we do, we need to talk about limits of integration. Remember I told you these limits are y values. What's the smallest y value for my rectangles? 0. And the highest?
4.
Not 4. It's 2. Not because of this 2, but because of that 2. Okay? 0 to 2. So we're now going to write it as 0 to 2 of the second x equation, which is this one, y plus 2, put it in parentheses, minus the other one, y squared, put it in parentheses, dy. That's what you're going to type in the calculator, right there. Okay? So, as soon as you write that down, get your calculator. Now, when you type in these y's, these are not y1s and y2s. They are just straight y's, and I'll show you where they are. So, we're going to go to Math 9, 0 to 2. Let everybody catch up with me. Okay, look on your keyboard for a letter Y, a regular letter Y. Do you see where it is?
1.
Above the number 1. So you need to type alpha and 1 to get that Y. Oops, I forgot my parentheses again. So parentheses, alpha Y plus 2, close the parentheses, minus, open the parentheses again, alpha Y squared, close, move out, and alpha Y in the dy. You with me? Push enter. Is that the same answer we got a minute ago?
No.
Almost. It is to 3 decimal places. And actually, this is the more correct answer. It is 10/3. Okay. Now, do I have any questions at this point? Okay. Here's the big question of the day. If I had typed this whole thing in with x's instead of y's, would I have gotten the same answer?
You change the equations and you change the limit of integration.
If I just typed this whole thing, just as it is, with x's instead of y's, do you think I'd get the same equation?
Yes.
Let's test it. You don't have to do it with me, just watch. I'll do it. 0 to 2, parentheses x plus 2 minus x squared dx. Same equation. Boom. Look at that. Same thing. So, do you have to type in y's to get the answer? No. You can type in p's or x's or q's or whatever you want. Okay? So, if you don't like going alpha 1 all the time, just type it in as x's. Just don't change the values. Just make sure you type it in with a different letter. Any questions? Okay, I have one more problem to do, and then we will be done and get to work. I'm going to a new sheet of paper. Are we good? Okay, move over there. Last problem. This one says, which way, comma, dx or dy. You need to be able to look at a problem and tell whether you can do it with dx's or you can do it with dy's. The last one you could have done either way, because you could have broken it into two and stick with dx's, or you could have just done the one and done it with dy's. Okay, here are the equations. Y equals x to the third, x equals y squared minus 2. Yuck. One is in terms of x, one is in terms of y, so it's a 50-50 shot. So what I'm going to do is I'm going to solve this one for y so I can stick it in the calculator. Otherwise, it's not going to do me any good. So y equals what? Y squared equals x plus 2. So y equals what? Plus or minus the square root of x plus 2. All right. Oh, that's kind of interesting. So, you need to go to the calculator. Let's bring it over here. It's just so dark today. I don't know why. Since the light's almost there. Y equals clear and clear. Now, x to the third, no problem. Okay. How do you put a plus or minus in the calculator? There's actually a couple of ways. I'm going to show you the easiest one. You put in the positive square root on y2, and you put the negative square root on y3. That would be the easiest. So the square root of x plus 2, and then the negative square root of x plus 2. That's the easiest way to do it. Just like so. Are we good? Zoom 4. Zoom 4. Okay. Now, do you see the area that we're talking about? It's this right in here. That really bizarre shaped thing. That's the area we're trying to find. So we need to sketch it. And it's really not that hard to sketch. If you can just draw a cubic, like so, and then draw a parabola that's moved 2 units over to the left. Try to make it as symmetrical as possible. And there it just creates itself. Okay. Now the question of the day is horizontal or vertical? Vertical is preferable. It's just easier. And if we started on the right, I'm doing this in pencil because I want to erase it. Am I hitting one curve and then the other curve every time? Yes. Yep. I'm good. I'm good. I'm good. I'm good. I'm good until I get to here. And then if I draw one over here, I'm hitting a curve and itself. That's not allowed. Do you see that here I'm hitting the parabola and I'm hitting the other side of the parabola? That's not going to work. So I have to do horizontal. I don't have a choice in this case. The last one I could choose either way. This one I don't have a choice. You must do the right minus left. Okay. So I'm going to draw them in with my red pencil. Right minus left, I am hitting curve on one side, curve on the other. We're good. So, in order to put it in the calculator, you must solve each equation for x first. Here's the first equation. If I take y equals x to the third and solve it for x, what's it going to be? Excuse me, solve it for y. Cube root of y. Do you agree with that? And the other one, they already solved it for x for me. x2 equals y squared minus 2. So now when I set it up, which curve is the right curve? The cube root is. So this is right, this is left. So in my case, it's going to be x1 minus x2 dy. Okay. Now, I need limits of integration. So, I'm going to come back to the calculator. This one is a little tricky, though. I made a mistake first period, and I don't want to make it a mistake this time since I'm recording it. Second, trace, intersect. This time we have 3 graphs in there. You've got to be sure you pick the correct graphs. So, for this crossing point, is the first curve x to the third? Does x to the third go through that point? Yes. Now, does this half of the parabola go through that point there? Do you see what I'm asking? Does the top half of the parabola go through that point there? No. So what I have to do is push down arrow. Now I've picked the other half of the parabola and I'm good. So push enter. It looks like they cross about -1. So I'm going to guess -1. And they do cross at -1. So this point right here is -1, -1. Are you with me? Everybody? Looking around the room, just making sure. Okay, now I got to do the other one. Second, trace, intersect. First curve. Is it the cube? Does the cubic go through that? Yes. Second curve. Does the top half of the parabola go through that? Yes, it does. And then guess, I think it's about 1. Push enter. Ooh, I got decimals this time. So, we taught you yesterday how to store these. Now here's the question of the day. Do I want the X or the Y? Whatever letter is here, that's what you want. Whatever is what you want. I want the Y. So I need to write down that Y value, 1.793 ... and I need to store it for something. What letter do you want to store it for? I don't care. Q? Let's do Q. That sounds good to me. Okay. So here's how you do it. Remember, I want you to go to the home screen, second quick. Type the letter Y. You have to tell it Y, and then store, and I want to store it for Q, which happens to be alpha 9. Okay, now it's there. So this is going from -1 to Q. Just for grins. Okay, I cannot type this in the calculator though, so I need to change it back to the equations. Let me move that aside for a second. So my one that I'm going to type in the calculator is going to be from -1 to Q. The x1 equation, which is the cube root of y, minus the x2 equation, y squared minus 2, in a parentheses, dy. Bless you. This step here is just setting the template for what you're going to write down. x1 I knew was the cube root. x2 I knew was the other equation. The parentheses, especially this time, are so important. So we're going to take the calculator. You can type this with x's or with y's or with q's or whatever you want. That q has to be a q. But yeah, you cannot type when you go to Math 9. You cannot say -1 to q with q's. That'll mess it all up. It has to be a different letter. So I'm going to do -1 to q, and then I'm going to type in what I see right here, parentheses. Stop quick. Do you know where cube root is on the calculator?
Yeah.
For those of you who do not know, it's math and number 4. There's your roots that are cube and other. Cube root of, I'm going to do x because I like x's. Out, close parentheses, minus, open, x squared minus 2, close, out, dx. And it's going to take a minute. It's doing a lot of math. One quick thing too about your calculator, 4.215. How do you know when it's working and when it's stuck?
That little line thing in
Up in the top right hand corner, you'll see something scrolling. Just a thin line that's scrolling. If it's scrolling, it's working. If it's like it's spazzing out, it's stuck. And usually to unstick it, just push enter, and then it should start scrolling. Okay, so watch that. If you're sitting there and you're thinking, man, this is taking a while, I don't know if I did something wrong. Look to see, is it scrolling up there or is it static and shaking like violently? Okay, if it's shaking, you're stuck. Because sometimes what will happen is you'll push enter and you'll accidentally push it twice. If you push it twice, it freezes it. Okay? Do you have any questions? All right, I am done. The rest of the day is yours to work.